This is Anand Goud, Assistant Professor from Civil Engineering Department. Today, I am going to discuss about the topic errors in accuracy. So, after completion of this topic, we can apply the surveying principles to chain surveying, leveling, and contouring for accurate data collection. So, after knowing about the accuracy and errors topic, we can do the surveying very precisely without any errors. Coming to the contents of this lecture, first topic is accuracy and errors and sources of errors in surveying and types of errors in surveying. Coming to the definition of accuracy, it is the degree of perfection obtained. So whenever you are going to measure the measurements in the surveying, so how precisely you are going to measure the particular measurements, so that perfection is called as accuracy. And this accuracy is depending upon the following three factors. The first one is precise instruments. Okay, so the use of these precise instruments simplify the work and saves the time and provide economy. So if you use precise instruments like which are having very calibrated equipment, then with the particular equipment we can directly conduct the experiments without any setup. And then due to the time constraint, due to the time constraint when you take the instruments, so it is also going to save the time if you complete the surveying within short time, and then provide economy. So sometimes we are going to take a rent of those equipments like a total station for one day. We are going to measure some area. Suppose if you won't get the preciseness while doing the surveying, then it may take longer time, so that you have to increase the days of surveying. So it is going to increase the economy as well, right? And next one, precise methods. So the use of precise methods will reduce the effect of errors. So what are the methods you are going to use? So if you know the methods perfectly, then you can do the surveying very perfectly. But if the method you are using is wrong, or else if you do any errors, any mistakes in the procedure, then it is going to take a lot of time and it is going to create the errors also. So that is why the method you are going to follow should be precise and it should be accurate. And next one, good planning. So good planning include proper choice and arrangement of survey control and the proper choice of instruments and methods for each operation. So depending upon the operation, you are going to use different types of equipment and a set of equipments also, set of tools also. Suppose if you take chain surveying, so in that you are going to use chain, and along with the chain you are also going to use arrows also, for marking the areas and points. So if you want to use set of tools, then that is going to reduce the time and it is going to reduce the error also. So good planning is very important, because depending upon this type of surveying, you are going to set tools which are required for the particular surveying. And these particular errors good planning will save the time and reduces the possibility of errors. So if you plan before the start of surveying, then that it is going to save the time as well as it is going to reduce the errors also. Coming to the definition of error here, the difference between the measurement and true value of the quantity measured is the true error of the measurement and is never known. So error is nothing but the measurement. It is the difference between the measurement and the true value of the quantity measured. So we will be having some length for particular object or for particular distance, right? So after measuring, you may not get the same length depending upon the type of instrument, or else due to the errors due to the person. So you may not get the same value as it is. So this particular difference will be there as always. We cannot know the true value of the particular object or particular measurement. So that particular difference is called as an error. And these errors can be categorized into following forms. The first one is systematic errors. And the second one is random errors. Third one is mistakes. These are the common error types. And coming to the significance of error. So before going to start our surveying, you should have proper knowledge about the error, so that you can do you can take some precautions while doing the survey. So first one is realistic expectations. So acknowledging the presence of errors allows surveyors to set pragmatic goals for accuracy in their work. So if you have prior knowledge about the errors, like depending upon the equipment and depending upon the method you are using, you will be having some knowledge about the errors, right? So if you have this knowledge, it is going to um, reduce the pragmatic goals, like if you practical errors. Okay, practically what are the errors you are going to follow, or else, sorry, you are going to get practically what are the different types of errors you are going to get, that is different, right? So that errors will be, you will be understanding the type of errors if you have the knowledge about the errors. And next one, enhanced precision. A deep understanding of error sources and types empowers surveyors to implement strategies that minimize their impact, thereby improving the overall precision. So enhanced precision means if you know the what are the types of errors we are going to get for type one particular type of surveying, then you are going to take some care, or else you are going to implement some strategies according to that particular type of surveying, so that we can minimize the errors and their impact. Okay, that is the second one. And next one, quality assurance. So familiarity with the errors enables the implementation of robust checks and balances. So if you know the errors, I mean, if you have the knowledge about the errors, then you are going to take care before the start of surveying, that like you are going to check the instrument whether it is calibrated or not, and you are going to check the area before the survey. Okay, depending upon the type of surveying, you are going to check the area, and you are going to check the instruments, and you are going to check whether all the equipment is available or not for that particular type of survey. So that is going to improve the quality of the surveying, and it ensures the reliability of the survey results. So if you have quality surveying, quality assurance, then that particular surveying is going to give good results. Next one, informed decision making. That means comprehensive knowledge about errors enhances a surveyor's ability to make sound judgments in varied field conditions. So if you have prior knowledge about the surveying, that is going to make you to judge the surveying or else errors before the start of surveying itself. So if you have prior knowledge, then our decision making will be very good, and this is going to reduce the time, as well as it is going to improve the results. Next one, the elusive nature of true error. So what is true error and how it behaves? Okay, it is very difficult. Okay, so a critical aspect of surveying error is that their exact magnitude remains unknown. So whatever the area we are going to survey, that exact magnitude maximum we cannot know, and this uncertainty arises from the fact that the true value of any measurement is never known with absolute certainty. Okay, we will not know the true error of any particular object. Okay, some people will measure in a different way. They will use same equipment, but while doing the surveying, you may get small errors. Okay, that is why it is very difficult to measure the true error. And surveyors work with estimates and probabilities, constantly striving to maintain errors within acceptable limits. So whoever is going to survey, he is going to estimate the results, or else he is going to have lot of probabilities while measuring the dimensions or objects, right? So everyone, whoever is going to do the survey, he is going to make sure that he wants to, I mean, he will reduce the errors, and if you get errors also, that will be within the limits. Okay, within the acceptable limits for the specific task. And next one, sources of errors. So how we are going to get the sources, and what are the causes for the errors while doing the surveying? See, errors in surveying can be arise from various sources. Understanding these sources is crucial for surveyors to minimize their impact. So from where we are going to get this particular source errors? What is the reason? So if you know about this, you can minimize their impact while doing the surveying. And the main categories of error sources are, first one is instrumental errors. Okay, the first source is instrumental errors, and these errors occur due to the imperfections in the surveying instruments or improper use of their instruments. Okay, this type of errors will be obtained from the instruments only. Okay, and if you won't use the instrument properly, then you are going to get this type of errors. First one in the instrumental errors is defective instruments. So errors may arise from the faulty or poorly calibrated instruments. Okay, if the calibration is not done properly, then you will get the errors while measuring the dimensions. Okay, and faulty equipment. Okay, if any equipment is not particularly aligned, okay, then also you are going to get the errors from the instruments. Okay, for example, theodolite with a misaligned axis. So if it is not calibrated from properly, then this theodolite in this theodolite, you are going to get this misaligned axis. Next one, imperfections in adjustments. Okay, so if the surveying instruments are not correctly adjusted, okay, errors can be occurred. Okay, so if the surveying instrument like bubble, okay, level bubble is there, right? So if the level bubble is not perfectly aligned, okay, it is not level, then you may get the error. So that is due to the imperfection in adjustment. Okay, and next one, manufacturing defects. So slight imperfections during the manufacturing process of instrument can lead to errors. Okay, so while manufacturing the instruments, if the alignments are not good, if the dimensions are not good, then also you are going to get the errors. Next type of error is natural errors. See, these errors are caused by environmental conditions that affect the measurements. Okay, so the first type of natural error is temperature variation. So in this particular temperature variations, changes may be occurred due to the temperature, which can cause the expansion or contraction of measuring tapes or chains. So if you do the chain surveying, due to the temperature, high temperature, the chains may expand. Okay, that is going to cause the incorrect length measurements. Okay, while measurements. Next one, wind. So strong wind can affect the plumb line and stability of instruments, especially in leveling and angular measurements. So when you do the level surveying, then there may be effect of wind, okay, which is going to cause leveling and stability of the instruments. Next one, refraction. Atmospheric refraction can cause the line of sight to bend, which affects the measurements and especially over long distances. So it is going to affect the line of sight, okay, which is very important when you measure the long distances. And next one, gravity variation. Variations in gravitational pull in different locations can slightly alter the results of precise instruments. So due to the gravitational variation also, depending upon the location, there will be some deflections in the compasses. So that is going to change our results. Next type of error, natural error, is personal errors. So these errors arise due to the limitations or mistakes of the surveyor. Okay, due to the mistakes of surveyor, we are going to get this type of errors. Incorrect reading. So misreading the scales on instruments. Okay, for example, reading an angle from the theodolite. Okay, if you read incorrectly the values, then it is going to read the incorrect reading, and it is also a personal error. Okay, and inaccurate measurement. Errors can occur if the surveyor does not correctly align the instruments or properly measure distances. Okay, so inaccurate measurements means if the surveyor, while doing the surveying, if the alignment is not good, suppose if you take the chain, if the chain is not properly laid on this ground like this, then it is going to give different dimensions and different results, right? So that is the inaccurate measurements. And next one, parallax error. This occurs when the surveyor eye is not directly in line with the measurement mark on an instrument, leading to incorrect readings. So if the alignment is not good, okay, if the line of sight is not aligned with the center, then also you are going to get the error. That is personal error. And next one, human limitations. Physical limitations like fatigue or even carelessness can introduce errors into the survey results. Okay, if you neglect the surveying process, then also you may get some errors. That is personal. Okay, and next one, miscellaneous errors. So these errors do not fall neatly into any above categories, but can still affect the accuracy of the survey. So these miscellaneous errors will be not categorized, but they are also leading to the wrong errors, okay, wrong results in surveying. Okay. The first one is mistakes. So simple human mistakes such as recording data incorrectly. Okay, if the data is not read properly, and arithmetic errors, okay, calculations can lead to errors in the final results. And next one, instrumental setup, incorrectly setting up the instruments. For example, if you take improper leveling of theodolite or total station, that is going to introduce some sort of errors, okay, which can lead to the wrong results in the surveying. Next one, coming to the types of errors in the surveying. See, understanding the nature of errors is crucial for surveyors to manage and mitigate them effectively. And these errors in surveying are generally classified into the following types. The first one is systematic errors. Okay, systematic errors means they are going to follow a consistent pattern or mathematical rule. Okay, while doing this particular surveying, while doing any type of surveying, these errors will, we will get the errors regularly. Okay, with the same pattern. Okay, in the same way. That means it is going to maintain that percentage. Okay, and they have specific characteristics. Like first one is predictability. Okay, these errors occur from well understood causes and can often calculated or predicted. Okay, we can predict this type of errors. Okay, and consistency, they tend to have the same magnitude and sign under the same conditions. So if you do any type of surveying under some fixed environment conditions, then the error percentage or else the error magnitude will be same. And cumulative nature means the systematic errors can accumulate over multiple measurements and potentially leading to significant inaccuracies if not addressed. Okay, these particular errors will be addressed in the surveying so that we can get the accurate results. Otherwise, they are going to give wrong results. Next, examples of systematic errors in surveying. Okay, so here see incorrect instrument calibration. Okay, so in the systematic errors, incorrect instrument calibration is one of the error which we are going to follow while doing the surveying. Like we are not going to follow, but we can observe these type of errors regularly in the survey. Misalignment of instrument components. Okay, if the instrument components are not aligned properly, and this is the mostly occurred error. And next one, errors due to refraction in optical measurements. So there is an effect of refraction in the surveying. So this is also called as a systematic error. And errors caused by the Earth's curvature in long distance measurement. So anyway, we are not going to control this particular error, and this we can observe every time in the surveying whenever you are going to measure the long distances. And next one, consistent personal bias in reading instruments. So person to person, the survey while doing the surveying, each person will read the errors or read the measurements in a different way. So some people, due to the negligence, they may get some manual errors, right? So this type of consistent personal biased errors are called as a systematic errors. Next one, to address systematic errors, supervisors should follow these particular standards. See, regularly calibrate instruments against known standards. So while manufacturing the instruments, they are going to give some guidelines or they are going to mention some standards for calibration. So regularly we have to calibrate that instrument as per the mentioned standards so that we can reduce the errors percentage. And next one, apply mathematical corrections based on known error patterns. So apply mathematical corrections. Suppose if there is any particular known patterns are there while doing the surveying, if you get any errors, you have to apply the corrections also for that. Okay, and use compensating methods such as taking measurements in both directions. Suppose if you have point A here and point B here, so while doing the surveying, you are going to place the chain from here to here, and you are going to measure this distance. So to control this particular systematic errors while doing this surveying, you may get small errors, right? So to control or to mitigate this, you just have to measure the distance from here to here as well as from here to here, so that we can control the particular errors, and it is also called as a systematic error. So use compensating methods like taking measurements in both the directions. And next one, employ more advanced instruments that automatically correct for certain systematic errors. So if you use advanced errors like ADM or total station, for example, then they can correct the errors. Okay, they are going to take that error percentage and it is going to give the results. And this is also one of the one of the point we are going to concentrate while doing the surveying. Next type of errors are accidental errors. See, they are also known as random errors. Okay, accidental errors have different characteristics. So why we are going to get and how we are going to get. See, unpredictability. So these errors occur due to the combination of factors beyond the surveyor's control. Okay, while sometimes while doing the surveying, while using the instruments, randomly we are going to move the instruments, right? Without our intention, we are going to move the instruments, and there may be chance of vibrations in the instrument due to the application of some forces. So these type of errors we cannot expect. Okay, we cannot predict those. And variability, they can be positive or negative in and vary in magnitude. Okay, so the variability while doing the while measuring the distances. Okay, there will be some variability, and they may be in positive way, or they may be in negative values. Okay, and they may vary in the magnitude also. Okay, the magnitude values also changes due to this particular variability. And next one, statistical nature. So over many measurements, accidental errors tend to follow statistical pattern, often approximating a normal distribution. So examples of accidental errors include slight variations in instrument readings, okay, due to vibrations or minor fluctuations in how a surveyor aligns the instrument. Okay, while aligning the instrument, sometimes you may get the vibrations or else minor fluctuations in the instrument. Okay, that is also going to cause these accidental errors. And next one, characteristics of accidental errors. Okay, they are unavoidable and present in all types of measurements. So these accidental errors, we cannot control this because we are not doing this particular survey. I mean, we are not getting these errors intentionally. Okay, at any point of time and at any site, you may get these errors, and we cannot control this. And their magnitude and direction cannot be predicted for any single measurement. So we cannot measure or we cannot predict this type of errors. Okay, their magnitude or direction. Okay, while doing the surveying, the instrument may move from little bit. It may move a little bit, right? So that particular movement or that particular type of fluctuations, we will not have. I mean, we will not have any proper idea about that. Okay, accidentally we are going to get, right? Their magnitude and direction we cannot estimate. Okay, and they tend to cancel out over a large number of measurements. Okay, due to these accidental errors, they are going to affect all the measurements. Okay, and they follow the laws of probability. Okay, we cannot predict this particular. Okay, probability is more for this particular accidental errors. And next one, methods to minimize the impact of accidental errors. So what we can do if you want to reduce this particular accidental errors means increasing the number of observations and using their average. Suppose while measuring any area by using any particular sort of surveying, okay, if you do this particular surveying at once, in that particular situation, you may get small fluctuations or small movement in the instrument, and that is going to give some X results. Okay, but if you repeat the same experiment, same surveying for number of times, okay, these accidental errors may not repeat. Okay, we are not following one particular pattern, right? So in this method, suppose if you repeat the experiment for the second time, there may be chance of getting there may be chance of avoiding the accidental errors. So that will result in a positive result in the surveying. So that is why whenever you are going to do the surveying, if you get any particular accidental errors, then repeat the experiment, repeat the survey, so that you can reduce, or else you can take the average values by using the repeated experiments. And next one, using the statistical techniques like the least squares method for adjustment. If you use least square method, then also it is going to reduce the accidental errors. And next one, employing more precise instruments and measurement techniques. Okay, if you use more precise instrument and measurement techniques, then you will reduce the effect of accidental errors. And next one, conducting measurements under optimal conditions when possible. Okay, whenever, in optimal conditions, suppose if the environment is good and if the instrument is availability is good and if the sources are good, then conduct the experiment so that you can reduce the size of these particular errors. Next type of errors are mistakes. Okay. Although not technically classified as errors, mistakes are an important consideration in surveying and accuracy. Okay, so we are not going to categorize as a one particular type of error, but this effect will be more on the survey. Coming to the definition, mistakes are blunders or gross errors that results from carelessness, poor judgment, and misunderstanding. So the definition of mistakes are nothing but they are going to arise due to the carelessness. Okay, while doing the surveying, you are not going to take care while using the instrument. Okay, the alignment of instrument is not good, or else reading of measurements is not good. Okay, and poor judgment and misunderstanding. So due to the misunderstanding also and due to the poor judgments also, we are going to get the less. We are going to get the mistakes in the survey. The next one, characteristics. Unlike systematic or accidental errors, mistakes do not follow any mathematical or physical law. So these mistakes will not have any type of pattern. Okay, we will not have any pattern, or else we will not have any physical law or mathematical law. Okay, and impact. So mistakes can significantly distort survey results and are often larger in magnitude than other types of errors. Okay, so these mistakes can significantly distort survey results. Okay, due to these mistakes, the results will be wrong, and sometimes they may be larger than the normal actual errors. Okay, different types of errors. And examples of mistakes in surveying. So what are the different types of mistakes we are going to do while doing the surveying? Means the first one is misreading an instrument. Okay, reading an instrument is very important while doing the surveying. So misreading is also one of the major mistakes while doing the surveying. Okay, like if you have a value of 14.3 meters, so some people will tell that it has 41.3. Due to the confusion, they are going to misread this. And transposing digits when recording measurements. Okay, and next one, using the wrong units of measurements. Okay, we have to use accurate units depending upon the measurement, depending upon the instrument. And next, incorrect setup of surveying equipment. If the setup is not good, not properly aligned, then also you are going to get the errors, and this will be coming under the mistakes, because we will follow the pattern for one method. Okay, according to that we have to use the set of tools. And preventing and detecting mistakes. Okay, so implementing rigorous checking procedures. So how to prevent these mistakes? Means we have to regularly check the procedure, which type of procedure you are using, whether you are following the good correct procedure or not. Okay, and using redundant measurements and cross checks. Okay, you have to cross check the measurements. Okay, and next, maintaining clear and organized field notes. Okay, while doing the surveying, while noting down the values, you have to maintain a field notes, so that so that the errors percentage will reduce while doing the calculation. And next one, employing data validation techniques in digital systems. Okay, whatever the data you have collected, we have to validate that particular values. Okay, and proper training and maintaining focus during surveying work. Okay, those who are doing the surveying, they have to take proper training, and we have to focus the surveying object. Okay, on which object or which area you are going to survey, we have to focus on that, so that you can prevent the mistakes. Now coming to the error mitigation strategies. Okay, to reduce the errors percentage and to control these errors, we are going to follow three strategies. The first one is instrument calibration. So regularly calibrating and adjusting the instrument will reduce the errors. Okay, regularly we have to calibrate the instrument, so that we will reduce the error percentage. And environmental considerations. So taking measurements in favorable conditions or applying corrections for temperature or refraction, etc. Okay, while doing the surveying, we have to consider the environmental conditions also, like For temperature, we have to add the correction values also, and for refraction also we have to add some correction value. Okay, these are environmental consideration. And training and vigilance, so ensuring surveyors are well trained and attentive to reduce the human errors. So we have to train them very carefully, like we have to knowledge them for about the errors also, so that they are going to take care while doing the survey. So these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.